Hello and welcome back to OCR A-Level Computer Science, and this is the workbook answers, and we're on topic 3, exchanging data. This is part 2. We've already done the first 12 questions relating to compression and cryptography. We've moved on to hashing, and now we're working on databases. So as you can see here, we're going to be doing question 13 to question 23 of the workbook. Finish off with HTML and CSS, but that's in the next video. Okay, well, we're going to start with question 13, and we're going to state what is meant by normalizing a database, and then we're going to consider the following database, which is this one here, and we're going to be normalizing this in 3 different ways. So we start with question 13. State what is meant by normalizing a database, and this is only for 1 mark. So I've tried to use sort of an analogy in terms of tidying your room. So normalizing a database is like tidying up your room by putting similar toys, if you want toys, together in separate boxes. Okay? So putting the same items in similar boxes. This makes it easier to find things when you need them and keeps the room organized. But in terms of a database, it is a process of organizing its structure to minimize redundancy and dependency, ultimately enhancing data integrity and efficiency. Okay, so grouping items together or splitting items up into specific fields. Normalize the database to 1 NF. NF just means normal form. Okay. So we've gone from this one, and I've split it up into further fields. I could have gone one stage further in terms of the address, the venue address, by putting the postcode in a separate field, but we've basically taken the number, and put that into a separate field. Okay, and I've taken the venue and the venue address and split that up into 2 fields as well. Okay, so one normal form, 1 NF, will ensure that each cell contains a single atomic value, only one particular value, okay? Whereas before we had the email address and the phone number here, and we've got the venue and the address in this one. So I split them up into single atomic values, as we call them, atomic values, and there are no repeating groups or arrays. So that's 1 NF, 1 normal form. In the second normal form, we remove partial dependencies, ensuring each non-key attribute is fully dependent on the entire primary key. Basically, what I've done, I've split it into 2 tables. 2 tables that are linked together. We could argue with a foreign key in this case, for the artist. Okay, so I've got the band's info table, and I've got links to the booking info table. So you can see the band appears twice, but we don't need to know the email address and the phone number in this particular table. Okay, so I've split it into 2 separate tables, which can either work independently or be joined together, usually with a foreign key. So third normal form, in 3NF, we remove transitive dependencies, ensuring each non-key attribute depends on the primary key, which I mentioned before. In this normalization process, the band info stores information about the bands, okay, i.e. their email address and the phone number. The booking info table stores booking information, i.e. date, fee, and agent. Booking date, fee, and agent. And the venue info table stores information about venues. Okay, each table contains non-redundant data and is organized according to specific attributes, adhering to the principle of normalization. This structure ensures data integrity and facilitates efficient querying and maintenance of the database. Okay, so basically splitting it into like its lowest common form, if you think of it like maths. Okay, and that's for 10 marks. Here we go, network protocols. 15, state what is meant by a network. Okay, it's like a load of computers joined together and then talking to the world, talking to the World Wide Web. State what is meant by a protocol. Draw a diagram to represent a star topology network structure. 2 marks. Explain the difference between a client server and a peer-to-peer network. Okay, well, let's have a look at this. So a network, as you can see with the AI picture, a group of connected devices like computers and phones that can share information and resources. Imagine a network as a big web of connected devices like computers, phones, and tablets. They're all linked together so they can talk to each other and share things like files or internet access. It's like a big club where members can share stuff with each other. Okay, that's a network. A little bit much there for 1 mark, but that sort of explains all of it. Okay, so question 16, what is meant by a protocol? Again, it's only for 1 mark, but I've gone into a little bit of detail, so try and make it as clear as possible. Protocols, these are rules for how devices communicate on the network. They make sure data gets to the right place in the right way. For example, TCP/IP is a common set of rules for the internet. Okay? Think of protocols as the rules everyone in the club has to follow when talking to each other. They make sure that when one device sends a message or file to another device, it is done in a way that both devices understand. It's like having a language that everyone speaks so they can communicate efficiently. For example, TCP/IP is one set of these rules used on the internet to make sure data gets from one place to another. Okay, so that's questions 15 and 16. Question 17, here we go. Again, I've used AI to draw me a star network. You can see there's a central server in the middle and all the machines are connected to it individually. And as you can see here, these are some of the different types of network that are available. Bus networks, full connectivity, star network, tree, line, ring, and mesh. But we're looking at a star network, which just looks like a star. Okay, that would get you 2 marks just drawing that thing there. Please don't draw this. It might take you quite a while. Still for 2 marks. Explain the difference. Explain the difference between a client server and a peer-to-peer network. Okay. Well, if I just go back, peer-to-peer network is like full connectivity. We've got a server-based network. As I said, the server is in the middle and all the machines are connected to it. Whereas a peer-to-peer network, they've all got their own sort of the hard disk, the storage. Each computer is linked to each computer. So they're all linked together. Rather than having one sort of central server, all the machines are linked together like this. So a client-server network. In a client-server network, there are 2 main types of computers, the clients and the servers. The server is like a big boss or a central hub, like that in a star network. It stores important information and provides services like storing files or hosting a website. The clients are like the workers or visitors. They ask the server for things they need, like accessing files or uploading web pages. Okay? Whereas a peer-to-peer network, there's no big boss or central hub like in the client-server setup. Instead, all the computers are equal or peer to each other. They share resources directly with each other, like files or internet connections, without needing a central server to manage everything. It's like a group of friends sharing toys or games among themselves without one person being in charge. Okay, so that's the difference. Question 19. Draw a diagram to represent how data is sent in a circuit switching network. And then 20, draw a diagram to represent how data is sent in a packet switching network. Okay, I've done a video for IGCSE in terms of data packets, which I'm going to link at the end of this video, which would be very, very useful for you to watch. So, but in the meantime, I'm just going to try and explain what each of these two are before I give you the diagrams, what each of these two things are. So, imagine you're sending a message to your friends using 2 different methods. In circuit switching, it's like making a phone call. Before you start talking, the phone line connects directly to your friend's phone. It stays connected until you hang up, even if you're not talking, if there's a pause in the conversation. So the line is yours, exclusively yours, during the call. But if you're not talking, it is still reserved just in case you want to start talking again. Whereas packet switching is like sending text messages. Instead of one long phone call, you send short messages, each containing a piece of your conversation. This is where data packets come in. These messages can take different paths to reach your friend, and they can even go through different routes. Your friend's phone gathers all the messages and puts them together in the right order to understand what you're saying. So that's sort of the difference there. So here we go. Circuit switching. And again, I've used an analogy. It's like having a dedicated road just for you to drive on. But it's always reserved even if you are not driving. Packet switching is like sharing a road with others. Your messages take turns using the road and it's flexible enough to handle different routes of traffic. In simple terms, circuit switching is like having your own lane on the highway, while packet switching is like sharing the road with others, taking different paths to reach the destination. I hope that makes sense, but that would be a diagram. These are switches, office switches, okay? And a physical connection is set up when the call connection is made. So this is like a reserved line. And this is on the video which I'm going to share with you at the end. In packet switching, we send data packets across the network, across various lines to the other person, in this case host 1 and host 2. So we break the message up into little packets, and these packets can go in any direction, okay, along the network, choosing the best path. At the destination, the packets will need to be reassembled into their correct order. using information sent in the packet header. Again, watch this video. At each stage in the transmission, there are nodes. These are nodes, node A, B, right all the way down to node H, okay? And these nodes contain a router to send the packets in various directions. Each router will determine which route the packet needs to take in order to reach its destination, okay? It's usually the optimum route. So that would be a diagram that represents packet switching, okay? So, question 21, 22, and 23. State 3 types of transmission media that can be used in a network. Okay, well, I'm assuming they're talking about the various connections. So we've got copper cable, okay? These are like the wires you see in your home. They're good for short distances and are commonly used for things like Ethernet cables that connect your computer to the internet router, okay, router. Fiber optic cables, here we go. These are like really thin glass wires. They're super fast and carry a lot of data over long distances. They're commonly used for internet connections that go across cities or even continents. You might have fiber optic cable in your house for either cable TV or for your actual internet connection. Okay, and then finally, wireless, which doesn't have any cables. This is like Wi-Fi or Bluetooth. Instead of using cables, it uses radio waves to send and receive data. It's really convenient because you can connect to the internet without any wires, without having to plug your device into anything. And then question 22, describe the role of a router in a network. I've got my router here, a little bit like a server with the devices connected to it so that all these devices can get onto the internet. But what does that mean? Okay, well, the router is like a traffic cop of the internet in your home. Its main job, and I'm sure you've got one of these in your home, its main job is to direct the traffic, to make sure data from your device, like phones or laptops, gets to where it needs to go, whether that's to another device in your house or over the internet, out to the internet. It connects networks. If you have different devices using different types of connections, like Wi-Fi and Ethernet, the router helps them all talk to each other and protect. It also acts as a security guard, keeping an eye out for bad stuff trying to get into your network, into your home from the internet. Okay, so yeah, that's what a router does. Then finally, describe the role of a domain name server in the internet. Okay, here they are, all looking at a domain name server where all the domain names are kept. But what is it? For 5 marks. Okay, so the role of a domain name server in the internet. Think of the internet as a giant city where millions of buildings, or websites, live. Each building has its own address, which is known as an IP address. But remember, all those numbers would be impossible to remember, all these IP numbers. Yeah, that's where the domain name server comes in. What does it feature? It features a translator, a directory, and speeds things up. The DNS is like a translator. When you type in a website name like google.com, it translates that info into the website's real address, i.e. an IP address. IP addresses are usually made up of 12 numbers or 4 blocks of hexadecimal numbers ranging from 0 to 255. So it's big numbers. So it'd be very difficult to remember the 12-digit number for example, Google. But the DNS server basically recognizes this google.com and it finds the actual IP address so you don't have to. Okay? It's like a big phone book for the internet. When your device wants to visit a website, it asks the DNS server to look up the address for that particular site. Just like you'd avoid looking at your friend's phone number in the phone book, you just type in your friend's name, okay, and ask to call your mum, and you don't need to remember your mum's number because it just says call mum. Back in the day, back in olden times, we did used to have to remember numbers. Speeding things up, it keeps a list of these translations handy, so when you visit a site you've been to before, it doesn't have to look up that address again. It speeds it up, it makes the internet browsing faster. It stores this information in things called cookies. Okay, that's question 23. That is it. That is it for this video. We have one more video to go for this topic, so see you next time. Thank you very much indeed for watching. Bye for now. Please continue to ask questions, leave your comments, hit notifications, and please subscribe. And finally, if you wish to buy me a coffee, I'd be truly grateful. Please visit buymeacoffee.com/learning zone. Thank you very much indeed. See you next time. Bye for now.